Welcome you all. First of all, thanks for being here in my YouTube channel. Let's see the problem. A three-phase 400 volts motor takes an input of 40 kilowatts, 0.45 lagging. So three phases, VL is equal to 400 volts is given, and then power is given 40 kilowatts, and cos phi is given 0.45 power factor. And then what we need to calculate? Find the readings of each of the two single-phase wattmeter connected to measure the input. W1 we need to calculate, and then W2 we need to calculate. So what is the formula for W1? VL IL cos 30 minus phi, and W2 is VL IL cos 30 plus phi. If it is a leading power factor they mentioned, means you have to interchange the formula, here plus, here minus. Okay. So I'll be calculating phi now. Phi directly can calculate, right? Phi is equal to cos inverse of 0.45. You will get 63.2 degree, right? Just to substitute over here. What we need to calculate here, VL is known value, and then IL we need to calculate. From the power we can calculate, right? Power is equal to root 3 VL IL cos phi. So if you want to calculate IL is equal to power divided by root 3 VL cos phi, right? So this is 40 kilowatts divided by root 3 VL is 400 into cos phi is 0.45. Finally, we'll get IL is equal to 128 amps. Okay, just to substitute over here, W1 is equal to VL IL cos 30 minus 5. VL IL cos 30 minus 5. Just to substitute over here, VL is 400 into IL is 128 into cos of 30 minus 63.2. You will get 42.91 kilowatts. Okay, 42.91 kilowatts. Similarly, W2 is equal to VL is 400, IL is 128 into cos of 30 plus 63.2 degree. We will get minus 2.9 kilowatts. Next problem, a balanced star connected load of 8 plus J6 ohm per phase is connected to 3 phase 230 volts supply. So I'll draw the diagram now. Star connected load, all the impedances are equal because it's a balanced, right? The supply voltage is given 230 volts 50 hertz, right? So this impedance is given per phase 8 plus J6, that is R plus JXL. Okay. And what is the relationship between line voltage, line current, phase voltage, phase current of a star? IL is equal to I phase, VL is equal to root 3 V phase. See here, there is a 230 volts, 50 hertz line voltage, not a phase voltage. Usually in all the problems, they will give 230 volts is a phase voltage, and 400 to 440 volts is a line voltage they will give. But they are given here 230 as a line voltage. Okay, so I'll be calculating phase voltage now. VL by root 3, that is 230 divided by root 3, you will get 132.7 volts. Okay, now I need to calculate line current. IL is equal to I phase is equal to V phase by Z phase. Z phase we don't know. I'll be calculating Z phase now. Z phase is equal to R plus JXL. We can substitute directly. So root of R square plus XL square, phi is equal to tan inverse of XL by R, right? So Z phase is equal to root of 8 square plus 6 square, phi is equal to tan inverse of 6 by 8, right? So we got here 10 angle 36.86, right? So I'll be substituting over here. So here V phase is 132.7 divided by 10, we got 13.27 amps, right? So now what we need to calculate? Power factor. Power factor, two formulas will be there. Cos phi is equal to R by Z1 and R cos of this angle 36.86 will get 0.8, right? Directly can calculate. Okay. Next, what we need to calculate? Power reactive volt ampere. So reactive volt ampere, that is root 3 VL IL sin phi. So root 3 VL is 230 into IL is 13.27 sine of this one 36.86. 36.86 317 VAR. Okay. Next, there is a total volt ampere. Definitely, it's a apparent power. S is equal to V root 3 VL IL. That is root 3 into 230 into 13.27. We'll get 5286 watts. Okay. How we got this reactive power and an active power means I'll be discussing now. This is a vector diagram for RL circuit. This is root 3 VI sin phi, root 3 VI cos phi. This one is root 3 VI. This is total volt ampere. This is reactive power. This one is active power. A three-phase delta connected balanced load consumes a power of 60 kilowatts, taking a lagging current of 200 amps at a line voltage of 400 volts, 50 hertz. Find the parameter of each phase. So I'll be drawing delta diagram now, right? So this is delta. So inside there is a resistance will be there and inductance will be there, right? That is Z phase. Z phase is equal to what? R plus JXL, right? So the supply voltage is given what 400 volts, current is 200 amps, 50 hertz, and power taken is 60 kilowatts, right? So this is a delta connected system. We need to calculate this R and then XL. These are the parameter in each phase, right? So Z phase is equal to what? V phase by I phase. How to calculate I phase now? I phase is equal to delta connected system. IL is equal to root 3 I phase. So I phase is equal to IL by root 3, right? So what is the value? 200 divided by root 3. You will get 115.47 amps. Now we can calculate Z phase, right? Z phase is equal to what? Here VL is equal to V phase for delta. VL is equal to V phase. So Z phase is equal to V phase is 400 divided by 115.47. We'll get the answer as 3.464, right? 3.464. So, but Z phase in terms of R plus JXL, we want the phase angle, right? So, how to calculate phase angle over here? Power is equal to what? Root 3 VL IL cos phi. So, power is given 60 kilowatts. So, root 3 into VL is 400. IL is how much? 200. Cos phi we need to calculate, right? So, cos phi is equal to 60 kilowatts divided by root 3 into 400, 200, 0.433, and phi is equal to 64.341. This is the phase angle, okay? This is phase angle. Z phase in terms of this one polar form. Z phase is equal to what? 3.46 angle. This 64.34. You convert it into rectangular form. You will get answer as 1.5 plus J 3.125. This is R and then this is XL. If you want to calculate L value, XL is equal to 2 pi FL and L is equal to XL by 2 pi F. Finally, we get 9.9 Henry. Okay. Likewise, we can solve the problem. We will cross check the answer. Power is 60 kilowatts. IL is given 200 and VL is equal to 400. Power is equal to root 3 VL IL cos phi. So we calculated cos phi and phi over here. And then delta connection VL is equal to V phase. I phase is equal to IL by root 3. So we got this value. And Z phase is equal to V phase by I phase. We got 3.4641. Z phase is equal to what? Z phase angle will be there. Phi will be there. Usually solving the problem. So R plus JXL we want. So that's why I substituted phi over here. So finally we got R phase is equal to this one, XL phase is equal to 3.125. So if you want to calculate L, you will get 9.99.